Okay, let's talk about doing a titration calculation. So you've got a variety of things to deal with these. So how do you deal with this? First of all, we have to think about this as being partially as a stoichiometry question, because you're given information about one chemical and asked about another different chemical. So just like in stoichiometry, you need to start with a balanced equation. And you'll notice this isn't standard units of liters, so these will need to be converted to liters. But let's start with the balanced equation first. So it says HCl reacts with NaOH, and then we need to use what we know about single displacement reactions, because we have, double displacement reactions, because we have two compounds. The hydrogen will go with the hydroxide. So let me do that off to the side actually. Hydrogen goes with hydroxide. And please understand that hydrogen plus hydroxide is two hydrogens and an oxygen. That's foreshadowing because when I blurted out water, because this is water right here. So hydrogen with hydroxide makes water. Sodium with chlorine makes NaCl. So let's see. Is this the right formula for NaCl? Yes. Is that the right formula for hydrogen plus hydroxide? Yes. Two hydrogens, one chlorine, one sodium, and one oxygen. So everything's good. It's balanced as written. So that's good. We've got our balanced equation. Now we need to convert these to liters, because we can't do anything with milliliters. So I know that sometimes that you can make it work with milliliters if you just throw them in there, but it doesn't work 100% of the time, and you need to understand what you're doing. So let's make sure it's clear what we're doing. 45.6 milliliters of HCl times 1 liter is 1,000 milliliters. And that's going to give us 0.0456 liters of HCl solution. Technically, you should, if this was your final answer, you should write this using scientific notation, but it's not the final answer, so it's fine. And then for the other one, 14.03 milliliters, so 14.03 milliliters of NaOH. And we're going to do the same conversion. 1 liter is 1,000 milliliters, because milli means 1,000. So you put the big number next to the smaller unit, so the number 1,000 goes next to the milli. And that's going to give 0.01403 liters of NaOH. Okay, so that gives a pretty solid foundation for us to start, because we know how many liters of each. So we have standard units of liter, we've got our standard units of molarity, and we've got a balanced equation. So here's how we're going to do it. We are going to write our given. We have the volume and the concentration for sodium hydroxide, so that's the given we begin with. So we're going to say 0.1403 liters of NaOH times, and I guess that's a little off center, but oops, so it'll be fine. But we're going to put on top, actually no, not fine, I'm going to put that on center. Okay, so times what? All right, what do we do? Well, we start with this. So we have to break this down into its units. So 0.0750, just put the number right there. Molarity is moles per liter. And I'm just going to specify the chemical identity on each, NaOH. That way liter cancels liter, that's good. So now we have units of mole. So what do we do next? Next, we need the balanced equation, because we're trying to figure out our big picture that I'm going to try to do here is I'm going to figure out how many moles of sodium hydroxide I have, which is this. And then from there I'm going to go to moles of HCl, which is, I need to do that in this part. And then once I have moles of HCl, I'm going to take the number of moles of HCl divided by the number of liters, and that'll give me moles per liter, aka the concentration of HCl. So what I'm doing here is I need to do like stoichiometry. I'm going to look at the balanced equation. It has 1 mole of NaOH and 1 mole of HCl. And what that is going to give me is the number of moles of HCl. So let's do that on the calculator. So I just realized I miscopied the number. 0.01403. So 0.0143 times 0.0750 is equal to, whoops, and I just realized that's still wrong. 03 times 0.0750 is equal to that number. So I write that down as 0.001050 225 moles of HCl. And we're going to take moles of HCl and divide it by liters of HCl, which is this right here, 0.0456 liters of HCl. And moles divided by liters is concentration, it's molarity. So I've got the number already still in the calculator, and I'm just going to take that divided by 0.0456 liters. So what's that give? It gives this. Now, this is too small a number to write by itself. So let's first of all just write the raw number, 0.023075658 molarity HCl, or moles per liter HCl. You could also write moles per liter instead of capital M. But I'm going to round that and write it in correct scientific notation. So I'm going to convert to scientific notation on the calculator for ease. And how many sig figs should I use? Well, this number had 3 sig figs and it was part of the calculation. This number has 4 sig figs. This number has 3 sig figs. So I'm limited to 3 significant figures. So here it is as scientific notation. It's going to be 2.31 times 10 to the negative second moles per liter, or molarity, HCl. And I'm going to box that as my answer. That's the concentration of the unknown solution. All right, this is the general process that you'd want to follow. Now, that said, could you have done this all in one step? Yes, that would be acceptable. Let me grab a piece of paper and show you what I mean. Okay, so what if you want to do all this in one step, didn't have to stop to write things down? Here's another acceptable way to do that same one. You write this is the chemical you have 2 things for, so you want to start with this. 14.03 milliliters NaOH. And then you just do a whole bunch of calculations all in one big go. So what that means is it becomes 1 liter NaOH, 1,000 milliliters NaOH, which gives you a liter, which gives you your liters. And then you do the 0.0750 moles of NaOH per 1 liter of NaOH. This part came from your given right here, the concentration just broken into moles per liter, because this is the same thing as this. And then you do the same balanced equation thing, and you use the 1 mole HCl over 1 mole NaOH. That way moles cancel moles, and you get these numbers straight out of the balanced equation just as before. And then, if you look at what cancels, so milliliter cancels milliliter, liter cancels liter, mole cancels mole of NaOH, now you just got moles of HCl. You still need to divide by moles. Remember before, I ended by dividing by liters of HCl. So what I would do is I would say, okay, I know a volume unit needs to be down here, so I'm going to just write the 14 point, oops, wrong number. 45.6 milliliters of HCl. I'll just put a 1 up here as a placeholder. And then I could put a 1,000 milliliters of HCl contains 1 liter of HCl. And that would see milliliter cancel milliliter of NaOH, liter of NaOH cancel liter of NaOH, mole of NaOH cancel mole of NaOH, and milliliter of HCl cancel milliliter of HCl to leave moles of HCl on top and liters of HCl on the bottom. with this weird little 1 as a placeholder. And then if you do that calculation, 14.03 divided by 1,000 equals times 0.0750 equals, nothing really to do there, and then divided by 45.6 equals, and then times 1,000 equals, and then convert that to scientific notation, bam, you have the exact same answer. So you can choose to break it into small, easily understood steps, or you can do it as one giant step like this, getting the same answer, 2.31 times 10 to the negative second molar HCl. And that would work. Either way, though, make sure you have a balanced equation. But these are two perfectly fine ways to go about doing it. Whichever one suits you is the one you should do. Okay, so let's look ahead now to another one. Determine the volume of 0.1 molar sodium hydroxide needed to titrate 50 milliliters of 0.2 molar nitric acid. So once again, you're giving information about one chemical and asked about another. You need to do stoichiometry. Time for balanced reaction. HNO3 plus NaOH produces a double displacement reaction where hydrogen and sodium switch places. So the sodium will pair with the nitrate to make NaNO3, and then the hydrogen will go with the hydroxide. So hydrogen plus hydroxide is HOH, which is 2 hydrogens and an oxygen, which is water. So there you go. Now, that being what it is, 2 hydrogens, 2 hydrogen, 1 nitrate, 1 nitrate, 1 sodium, 1 sodium, 1 oxygen, 1 oxygen. So it's already balanced as written. We don't need to balance this at all. It's already done. Next, you can't work with anything in milliliters, so you got to turn it to liters. So 50.0 milliliters times, of HNO3. 1 liter is equal to 1,000 milliliters of HNO3. That gives 0.0500 liters of HNO3. Now we've got units we can work with, and we have a balanced equation. Be aware, it asks for volume, but it doesn't specify the units. If it doesn't specify, you need to respond to the units given. So it gives you milliliters. Be aware we will be responding using units of milliliters, which means we're going to get an answer in liters and then convert it back to milliliters. So here's how we go about doing this. See the one you have most information about, the nitric acid? That's what you start with. So we converted the milliliters to liters, so 0.0500 liters of HNO3 times this other one right here. We're going to break this into moles per liter. So this becomes 0.200 moles of HNO3 per 1 liter of HNO3. This is what molarity is. It's moles per liter. It's the number of moles in 1 liter. So we have that. If we do our math right now, liters cancel liters for HNO3, leaving moles of HNO3. But we're not trying to find HNO3. We're trying to find sodium hydroxide. So we need to look to the balanced equation and get a mole relationship. You'll notice it's a 1-to-1 ratio. So for every 1 mole of I read the wrong thing. For every 1 mole of HNO3, there's 1 mole of NaOH. And then, if we do that, so the cancel, we have moles of NaOH, we can take moles of NaOH and then use the concentration to find out the volume of NaOH. So let's do that. So 0.05 times 0.2 equals this. 0.01. Now 3 sig figs. We got to remind ourselves later on that we're going to need at least 3 sig figs. So this won't change the calculation any, but it's just a reminder, hey, don't forget to have 3 sig figs at least in your final answer. Or at least be aware that there's 3 sig figs here. But don't forget your units, moles, and don't forget your chemical identity, sodium hydroxide. Okay, so you're going to need that many moles of sodium hydroxide. So we're going to take this and write this again, and we need to figure out how to get volume out of it. So what we're going to do is we're going to say 0.100 moles of NaOH times, and then see this right here, and I just realized I miscopied the number, 0.0100. And then we take the concentration and break this into moles per liter. So we got to set it up in order to put 1 liter of NaOH contains 0.100 moles of NaOH. So I just took this and converted it to moles per liter, but I flipped it upside down. That way moles can cancel moles and leave liters as my answer. And if I do this, it's 0.01 divided by 0.1, so that's 0.100 liters of NaOH, because again, moles cancels moles. Now what happens when I take that is I go 1,000 milliliters is equal to 1 liter NaOH. And that gives me a final answer of 100, don't forget your decimal place to make it 3 sig figs, milliliters of NaOH solution, but I think I'll be a little more specific, of 0.100 molar NaOH are needed. Now, there was a lot of stops and starts with that. We could actually have done that all in one go. So let me show you an alternative solution that is equally acceptable. Now you still have to balance the equation. There's no getting around that. But you could have started the same way as we did with what you're given, the HNO3. 50.0 milliliters HNO3 times 1,000 milliliters is 1 liter HNO3. And then this gives you liters, and then you use the molarity just like here. 0.200 mole HNO3, 1 liter HNO3 times, okay, this leaves you moles of HNO3, and then from the balanced equation, we get 1 mole of HNO3 for every 1 mole of NaOH, and then this leaves us moles of NaOH. We have this concentrated solution right here, so I just say, okay, fine, since moles of NaOH is here, it's got to go down here. 0.100 moles of NaOH for every 1 liter of NaOH. And then I tack on the conversion from 1 liter of NaOH to 1,000 milliliters of NaOH. And then if I run through all that, 50 divided by 1,000 equals times 0.2 equals divided by 0.1 equals times 1,000 equals the exact same number that we had before. And I ran out of space, so I'll do it here. 100 with a decimal point milliliters of let me be more specific, 0.100 molar NaOH. Okay, so really the only question is which one are you more comfortable with? Have a balanced equation either way, and you can break it down into small manageable steps, or you can just do it all in one piece. As long as you know what you're doing, pick the one that suits you best, and that should take care of it.